Good evening, everyone. Welcome to the second week's live session. So today we'll be discussing problems from. um Today we'll be discussing problems from the second week's content. But we'll wait for 5 minutes for everybody to join in, and then we'll start. Um, Hello. Good evening, everyone. So welcome to the live session. Just for a brief introduction, I am one of the TAs for the NPTEL Natural Language Processing course, and today we'll be discussing problems from the second week's content. Um, so let's get started. Yes, pardon. Did anybody say anything? Oh, okay. Good evening. Good evening. So yeah, so this is the first problem for today. So I would request everyone to try solving the problem for a couple of minutes, and then we'll discuss how to go about it. Okay, till now only like 7 to 8 people have answered the problem. I would request others to also join in and just try solving the problem and post their answers in the chat. Then we'll take it up. We'll wait for another minute. Everybody, please just try solving the problem. I think somebody is unmuted. I would request you to please mute yourselves. Mukkamala Rambabu, would request you to please mute yourself. Oh, okay. Um, I see a variation in the answers. Um, let's see. Okay. So Aditya Singh had first written AC, and finally the answer he thinks is D. So could you please explain, like, why do you think the answer is like, if you think it's D, why do you think the answer is D? I would request you to unmute yourself and just explain what you thought in when you were solving the problem. Okay, maybe then Mukkamala Ram Babu. Could you think option both one and two are correct? So what did you think? Like, why do you think option A is correct? Hmm. Okay. Okay, okay, right. Um, okay, fine, okay. Then I think we'll go over to the solution. Um, we'll just discuss the solution as well. So it's correct. So as correctly stated, so option A would be the correct answer, and the reason that was given by um, the student was also correct. So the second. Um, Yes. So this was a, I think, easy problem. This was though from the first week's content. I hope all of you have understood this problem. And if still anybody has any doubt, you can ask in the chat, or you can unmute and ask now. Does anybody have any problem in this question? Otherwise, we'll move on to the next question. Okay. Okay, then we'll go. Yes. Yes. So Zipf's law, remember we had discussed Zipf's law in the last week's lecture also. So in Zipf's law, what happens is we see that so the rare words, one second. So here we see just so he, sorry, just I had to admit a few people. Okay, so here we see that according to Zipf's law, there's this notion of where we can relate the number of words with the frequency. So only a small number of words, that is, we had seen the stop words or the function words, that is of the and or the articles and prepositions. So they occur with a very high frequency, and those would be the most highly frequent words in the corpus, whereas rarer words, maybe uh, words in pertaining to the context of the specific corpus, those words would be occurring with a comparatively lower frequency. So, those words, for example, maybe some specific nouns or some specific verbs that are there in the corpus, those you would observe at a lower frequency. So that is the intuition behind it. Was I able to explain? Okay. So we'll now discuss the second problem. So here again the question is, so we have a corpus C1 of 4 sentences which are as follows. Now we have to state what is the total count of unique biograms for which the likelihood will be estimated. And we are also assuming that there is no pre-processing involved. So again, please take a few minutes of time to solve the problem, and then we'll again discuss. So once you're done solving the problem, please post the answer in the chat. And once like sufficient number of students have solved the problem, we'll discuss the problem. So are everybody able to solve the problem? Is there any doubt anybody is facing that we need to discuss? Yes, we'll discuss the solution. I was just waiting for a few minutes to just for some people to solve the problem, and so then we can go ahead. I'll just wait for one more minute and see that how's everybody progressing, and then we'll discuss the solution. So if you have any doubt, also you can post it in the chat meanwhile, or if you have been able to solve the problem, then also you can post it in the chat. Okay, I think we'll go ahead and discuss the solution. So, so this is the solution. So the question was that we have to find the total number of unique bigrams. So one thing that we need to do is for every sentence, before the starting of the sentence, we need to add the start of sentence token. And after that, we need to add the end of sentence token, which is respectively the this s and sorry and slash s. So these are the start and end of sentence tokens. And after that, we simply have to bigrams means a pair of words, two words. So we have to take two words at a time, and that would give us the total number of bigrams. So let's go with this for the first sentence. So here is today is Nayan's birthday. So before today, we'll have a start of sentence token. After birthday, we would have a end of sentence token. So now to take bigrams, we need to take two words. So that would be start of sentence token today. That is one bigram. Second is today is. Next is Nayan's. And finally Nayan's birthday. And the last one would be birthday and the end of sentence token. Okay. Like that, you have to do it for the other sentences as well. And so that is how so there are two things here. One is the tokens that you have to add to indicate the start and end of the sentence. That was one thing you need to do, and after that you just have to like take pair of words, and that would give you the bigrams that are there in this corpus. So I think one of the students had posted the answer to be 24, so it's right. So 24 is the answer. So if anybody has any doubt in this question, please let me know. Yes, yes, yes. Uh, Pardon? The pair would be in according to the order of the sentence. So here, if you see, just a second. Here, if you see in the sentence, meaning here necessarily we are not taking into account the meaning, but here the word order should be in accordance to the order in which the word appears in the sentence. So you cannot, for bigram, you cannot take like today and Nayans. Like that you can't take. You have to take two consecutive pair of words. You need to be okay. Does that clear you out? Yes. About? Yes. Here. Okay, so this S, can you also see my cursor? Is my cursor also visible?
I think she is also for that is not put properly, ma'am. The token like S starting. She is also found of cream cake. There the S should come starting S. I think that is missing, and it is also ending S is missing for the fourth sentence.
Uh,
When like
yeah. Oh,
answer.
I got it. I got it. Yeah. So here you're saying there should be a start of sentence token, and here should be an end of sentence token. Yeah,
Yes.
correct.
Here
Right.
also end of the S with there.
Yeah.
Cream cake.
Right. Yeah, that's right.
So if we will put end of sentence, then cake at the end of the sentence.
Yes,
End
yes.
of the sentence.
Yes, just yeah, right. So so this one if we are discussing, so let's take the third one only. So she is fond of cream cake. So here before she there would be a start of sentence token. After cake there would be end of sentence token. Now we combine. So start of sentence token she is also fond of cream cake and the end of sentence token. Okay. Is the procedure clear with everybody?
Just know that answer once.
Yes. 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 Yeah. Yes. Hmm. Uh, so you're saying that because of the start of sentence token and end of sentence token, because of that you're saying that so those are also considered to be legitimate tokens. They are just like as you will see going ahead, they are used for processing purposes. So they are simply to demarcate where. So in a corpus, you would generally have multiple sentences, right? So there, these are used to like understand where a sentence is starting and where a sentence. Yes. Hmm. Yes, that is considered as a pair. Yes. So in start of sentence token today, the first word would be the start of sentence token. The second token would be today. So there are two tokens. Yes. Right. Yes. Okay.
Ma'am, I have a question.
Okay. One by one. Yes, please go ahead. One of you go ahead.
Yeah, so this is the follow-up question with what Ashwini madam had, right?
Okay.
That why do we need to consider the start of the sentence? Normally, bigram in the sense we go by the pair of the words. We take first word and second word and we make a pair, and second word and third word and we make a pair. That's how it's supposed to be.
Hmm.
It doesn't matter whether we have one sentence or the multiple sentences in a corpus. Right? So, what is the reason behind? And another question is
Hmm.
the algorithms what is available in the market.
Hmm.
I don't see they are using the start of the sentence
Like.
for any of the engrams to take a bigram or a trigram. Right? They
Hmm.
do the words physically. They take the words and do the annotation.
Okay. So which algorithms are you referring to exactly?
Um, any algorithm, if you are doing
Hmm.
some NLP processing or anything, right? The
Acha.
algorithms which are available right now.
Okay.
So they give, if you go with
So talking
NLP
about
processing,
packages that are available like NLT
yeah,
Card, Hugging Face,
packages
like
which
that.
are
Okay. So those are already systematic and uh, so they use start of sentence and end of sentence token, but they don't use this slash s or something. So I mean, that would be a bit high level to discuss over here, but they use the CLS token, separator token, all those tokens are there, still there to demarcate where one sentence is ending and another one is ending, another one is starting. So those are there that are happening on the back end. So those are still there. What is the reason? So the reason, majorly on yeah, what is the reason why we need to choose the starting? So I think this would be more clearer as you progress through the lecture. So I think so, like coming up, there would be like not algorithms. So there would be mechanism that we will be studying where we use these tokens. So these, so like we would see that we would like for example, we this would come up. Like in the upcoming lectures, that we want to know how probable is the word today to occur at the beginning of a sentence. So now, how do I understand what is the notion of beginning of a sentence? How do we understand as humans, right? But how do I make that computationally? How do I like how do I make a machine understand? So for that, we add a start of sentence token, and then we like ask the machine to count how many number of times the start of sentence token and today has occurred together. So that would give me an approximate count of like how many times today appears at the start of a sentence. So this is for computational feasibility.
To this, madam, I just want to add, like, we are
Yes, yes.
taking this as for a reference. The system will take it as a reference. Like, first it will attack from where it is starting. Starting token, it will put the first as a one word, and then again it is breaking it by graph. Is that so, madam? Ending also to remember which where it has ended and all that. That's why it is adding birthday as the end token.
It's for yeah demarcation purposes like yes.
Even the start tag and end tag is also for the same thing. Like it is marking it. It is
Hmm.
marking the entire sentence with the start and end. And the start of the tag is today. End of the tag is birthday. That's how it is trying to remember. And in between again it is making bigram, bigram, bigram.
Hmm.
Is that so, madam?
Yes, yes, yes.
So another question is,
Mhm.
in case of huge corpus, like
Hmm.
where let's take example of news articles,
Hmm.
there will be a follow up of the sentence. Like they have sentences
Hmm.
uh, merged with like in a period, right? Every sentence is ending with a period. So like this is kind of we'll have multiple paragraphs.
Hmm.
So that time when we generate the bigrams,
Hmm.
so we will take paragraph ending, paragraph beginning as a sentence. Madam, is that dot and all that or we consider, sir, what I feel. Dot and all is going to remove that all dots and blanks and all. I think it will not consider it.
So usually, yes, yes. So yeah, so usually when you are processing huge text corpuses like you're saying, first you have to do some sort of pre-processing. You have to like when one paragraph ends and one another paragraph begins, there would be new line characters there, and all those things would be there, right? So you have to remove all those things first. First, you have to pre-process that thing, and then ultimately you'll have sentences. All you would have sentences, and from there, then you follow the procedure that we discussed today.
Okay.
Yes.
Okay, ma'am. Thank you.
Okay.
I got it.
Ma'am, I have a doubt in third and fourth sentence, ma'am.
Yes.
So in third sentence, start with token is not considered. Why she is not considered? Directly she is it's been started.
Ah, okay. So that we discussed. There's an error in the slide. Correctly, there would be a start of sentence token over here. Uh, so
And similarly, cream cake is not available.
yes, yes,
Uh,
right. So
she
there's
will
a
also found of cream cake, then last token cake.
hmm, yeah.
Similarly, the fourth sentence also.
So
We
that white
will celebrate her birthday with will ice cream,
nice
cream cake, cake.
ice cream,
Yes,
cream
yes.
cake.
So,
Yes.
yeah, everybody, yeah, okay, fine. I understood your doubt. I'll explain it. So, I think just while we are explaining, I would request everyone to mute yourselves. Otherwise, like everybody, so there's a bit of a noise in the background. So, we'll discuss. I understood your doubt. So, the thing that we are doing over here is, as correctly pointed, so there is a mistake in the solution. So, there would be indeed, please,
Madam,
yes, please, just wait a second.
no,
Yeah, I'm discussing this and then I'll take up your question. So there would indeed be a start of sentence token before the third sentence, and that would so the biograms would be start of sentence token she is, and then following as you said. And even for the last sentence, there was a end of sentence token missing. So there at the end when we go, so initially you'll have the set of biograms, and it would be V ice cream, cream cake, cake, and end of sentence token. So that I hope the procedure is understandable for everybody. So there was a typo in the slides. I'll rectify it later. Yes.
So now, ma'am, lastly,
Ma'am,
I think just hold a second. Yeah, please go on. You had a doubt, right?
ma'am,
Yeah.
there
Yes. Yes. Please.
actually in our question,
Yeah.
it is asking about the unique bigrams,
Hmm.
and these two bigrams are appearing two times.
Okay.
So I think yes,
Hmm.
ma'am. The
Okay.
solution is correct, ma'am. Solution if is we correct. Consider one more time starting in the bracket here, yes, and she, then it will not be unique. Double she will become, and if in the end cream cake, if we consider two, then it will wrong one.
Okay.
Have to
Okay.
consider only unique.
Yeah. Yeah. Okay. Right. Right. Got it. So in the so so here in the second and third sentence, both of them start with she. So in the when we are considering the second sentence, then itself we are considering the bigram start of sentence token she, right? That is what you all are saying. Yeah.
Yes, ma'am. Only
Yeah.
one.
Yeah. Yeah. Okay. Yeah. Correct. Correct. I missed the unique part.
The
Correct.
same applies for the cake as
Right. 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 So that is also taking into account in the third sentence. So third sentence would have the bigram cake end of sentence token. So that is why it is not coming at the time of the fourth sentence. So that would be a repetition, right? Okay. So any other points that anybody would like to say?
well.
Okay. Does anybody have any doubts?
no, ma'am, it's clear, ma'am.
Okay. So this is the third question. Please try solving the question and please post your answers in the chat. We'll wait for a few minutes and then take up the solution.
Madam, we have a 3 gram model is here. Question is 3 gram. In this, it is giving 4 gram. In our assignment, it is 3 gram model.
That is these are practice problems, so these would be different. This would be different. Okay, I think a lot of people have already solved the problem. We'll go ahead with the solution. So, yes. So let's see. So all of you have said the answer is D. I'll just request one of the students. So let's see. Isha has said it's 3. So Isha, could you unmute yourself and say why do you think the answer is 3?
Ma'am, as the class or Marco model, the n-gram model is a n minus 1 order of Marco model. So that we have to substitute n is 4, n minus 1 is 3.
Okay, and what does n minus 1 order Markov model mean?
I don't know.
Okay, okay. Would anybody else like to take up the solution? Let's see. We'll discuss. We'll discuss this point, but let's see. Ganesh Nayak, would you like to add on to what Isha said? Okay. How about Sita Lakshmi? Would you like to?
Ma'am, good evening, ma'am.
Good evening.
Madam,
Yes.
I think first order Markov model means the current value depends on the previous one value only, ma'am. I think the Markov model is nothing but a current value depends on the previous value. That's why program is also depends on three, ma'am. That's why.
Okay, so you're saying a four-gram model, the current word would be dependent on the previous three words. So
Yes,
that makes it a
previous. Means and Markov model is first order or second order, third order. It doesn't mention, ma'am, here. Generally in first order only current value depends on the previous one value. To second order Markov model depends on the previous two values, ma'am, like that. But here it doesn't mention any which order of the Markov model. In program, generally in n-gram, we have to take the n minus 1, ma'am. That's why I put 3, ma'am.
okay, okay, okay. Uh, fine. So let's go ahead with the solution. So yeah. So as correctly said, so what happens is in a unigram model, I'll just take up the question that I asked. So in a unigram model, so say you have been asked to say the probability of the word office. This is an example from the slides itself. Um, so probability of office would be dependent on the word itself. Whereas if we take a bigram model, probability of office would be dependent on the previous word, which in this case was from. For trigram, in the word office would be the previous two words. So here what we have is, four-gram model would be dependent on the previous three words. So that gives us the answer would be D, that is 3. So which all of you were correct in whatever the answers that you gave in the chat as well as what you were explaining. So if anybody has any doubt, please let me know. I'll pause for a few seconds.
Can you explain again, ma'am?
Pardon? Can I explain again? Yeah, sure. So the question was, we were given a four-gram model. Okay, we were asked what would be the order of the Markov model. So here, one thing that we need to know is, I hope the slides are visible. So here, for a bigram model, when we are taking a bigram model, so here the a word would be dependent on its previous one word. For a trigram model, the current word would be dependent on the previous two words. Similarly, for a four-gram model, the current word would be dependent on the three previous words. So we can extend it. For the n-gram model, the target word or the current word would be dependent on the previous n minus 1 words, and that makes it the n minus 1 order Markov model. Well,
Can you just tell the sentence of this particular example? Complete sentence.
sentence as in the question you're asking?
No, the example which you have just now explained.
This example is from the slides. I think 15 minutes from office. That was the text. I have to check the slides though. Uh, the, the office is about 15 minutes from my house. That is the full sentence. Yes. Any doubts anybody has? Somebody had asked me the doubt, so was it clear for you? I sorry I could not note your name. Somebody asked me to explain it again, right? Is it clear now, or should I repeat again?
Yeah, ma'am, it's clear.
Okay.
So, madam, if it is a 2-gram model, then one order Markov model will be right.
Correct. And why would it be a one-order Markov model? Is that clear? It would be depending on one previous word, so that makes it a one-order Markov model. Okay.
Okay.
Yes.
only, ma'am.
Yes.
And for a unigram model,
Mm-hmm.
in order to count number of unigrams in a sentence,
Hmm.
will the start of the sentence and the end of the sentence itself will make a token?
Um, it would depend on the problem that you're handling. So, so they would be considered as tokens during the processing, but one thing, so the number of, so if you think it that way, the number of start of sentence tokens and the number of end of sentence tokens would be equal to the number of sentences that are there, right? So it doesn't add any value in the computation. Those are mostly used when you're using higher order n-gram models, or like, or when you're taking into account the entire context of a sentence, that is where it is used. So, so that is where it would be more useful, I would say. I think I need to always also be problem specific.
Okay, okay.
Mm. Okay, we'll move on to the next question. So the fourth question is, which of these is a valid Markov assumption? And there are four options. Please take a few minutes to solve the problem. Okay. So, the most of the answers that are there in the chat, some people think the answer is B, some people think it's D. So there's a confusion between whether the current word would be considered. So the probability, so option B is the probability of word depends only on the previous, whereas D is it takes into account both the current and the previous word. So I'll just request maybe let's see, Ashwini said it's D. Ashwini Neeta. Okay, so Neeta, maybe could you please unmute yourself and say why do you think D is the correct answer? Okay, how about Aditya? Aditya also thinks it's D. Would you like to say?
Yes, ma'am. In the previous question, you only told that Markov assumptions is depend on n minus
N
n
minus 1.
minus one word.
Yes.
So
Okay, okay, and yeah, I mean that's right. But we'll discuss the solution. Let's hear a few more students. Um, let's see. Uh, Rashmi Nixon Daniel. So you also think it's B, right? Why do you think it's B and not why are ACD wrong? Could you please say?
Maybe because taking two words into account, the next occurring word will basically depend on the n minus one word. So that may be the solution.
Okay, okay. We'll go in and discuss the solution now. So the answer is B. Uh, rightfully, so the probability of a word depends only on the previous word in this case. So dependence means the condition. We are conditioning words like over here we saw, right? Just a second. Here we saw, right? We are conditioning the probability. So this is what dependence means, right? So office is dependent on from over here. And the probability of office over here is dependent on the minutes and from the previous two words. That is what it means. So here we see, so the probability of word would depend only on the previous word, and that would be the only valid mark of assumption. So anybody has any doubt in this question? Ashish Sharma has raised a hand. Yes. Ashish, do you have a doubt?
Yes, ma'am. Ma'am, this probability when we'll be calculating, it will take into consideration joint probability and the probability of the condition word. So I think the answer should be B.
Answer should be D, you think? So when we are talking about here, the question is what is a valid mark of assumption, right? So when we are talking about mark of assumption, we mean that, so this was discussed in the uh, yeah, so you can see over here in the slides. So Markov assumption means that we are conditioning only on, so here this you are saying, when, so this is the joint probability of all the words in a sentence. And when we are breaking it down in terms of conditional probabilities, we get the probability of a word given all the words that come before it. But when we are taking into account Markov assumption, we specify that, okay, this word will be dependent only on previous K words. So we are restricting or limiting the context that is determining the probability of a word. That is that is what happens. So because of that, there is like only it would be dependent only on the previous words. So
Okay, ma'am.
okay, and okay, any other doubts?
Hello, madam.
Yes. Yes.
Can we say that auto completion is based on this marker assumption?
Autocomplete? Yes, yes,
Auto
it is. So in this week's lectures are also covered some basics of language modeling, language models, right? N-gram language models. So auto-completion would be like based on that intuition. Yes. Um, Anything else, or should we go ahead with the next question? Okay. So for the fifth question, we have this. So we have a string mash. We have to identify which of the following set of strings have a Levenshtein distance of 1. Please try solving the problem. Okay, we'll discuss this question. So, some people think it's C and some people think it's D. Um, let's see. So, Saurav Kumar thinks it's option C. So, Saurav, could you please explain why do you think C is the answer?
Ma'am, the vacancy distance is given 1. So we have to see that the word from our word, the maximum difference, like we have to see should be 1, not more than 1.
Okay, so all the words that are given in C have one distance.
Yes, ma'am.
Okay.
I think 1 distance means it is not like that, madam. Like when we are to get to make a smash, we need 1 letter from the smash.
Yes, yes, yes. I'll ask you, please. I'll ask the students. Anyways, we'll discuss the solutions. This we'll take one by one. We'll just take other students as well. Let's see. Kavita thinks it's D, right? So, Kavita, could you tell your thoughts why you think option D would be a correct answer?
No, madam, I understood now. Actually, it's correct only. C only I see.
Okay, you also think it's
That's
C.
one difference. Yeah, I understood.
Okay. Uh, okay, fine. Okay, we'll just discuss the solution then. So yeah, so here, so this is so Sir had taught edit distance, right? So there only we had seen that there are three operations. There is insertion, deletion, or substitution, right? So here why is C the correct answer? So from going from smash to smash, we're performing one insertion. So there would be we are adding S at the beginning. So because of that, smash has a level time distance of 1. Similarly for mash, we are deleting each, so that gives us again, like, so we are performing one operation. So you can extend that analogy for the rest of the words in this option.
How is for last second?
How is this for?
Last second.
Okay, mush, so you're substituting A with you.
Like
So
you are deleting U and then inserting A.
so
So it's 2 steps, right?
So here, substitution here, like here you're considering substitution as one. So there are cases as well where, as you're saying, so this has also been discussed. That's a different distance. I forgot the name. It's given in the slides as well, where you consider substitution to be uh, having a distance of 2, but in the normal level stand systems, all three are given, like, are considered to have a cost of 1.
Okay.
Anybody has any other doubt?
So we can consider either by adding one or deleting one or changing one. So all these three constraints we can consider.
Yes, yes.
Thank you.
Ma'am, I had one doubt. Ma'am, in fourth word in Mesh, we are substituting A by U, right? So can we perform insertion and deletion both so that the length and distance maybe I'm asking for another question. When they were asking for length and distance, so will Mesh will also be considered the solution of it?
Um, so we usually take the most optimal value. So, so here, if you're considering that if substitution has a cost of 1, and so substitution has a cost of 1, and if you're performing deletion and then insertion, so that would have a cost of 2, right? So that would have, so So you can say that way also, that first you're deleting a, then you're adding u. If you think like that, then level and distance would be 2. But if you're thinking in terms of substitution, then here like directly you're substituting a with u, and that directly gives you mush. So you have to think in terms of the operations. So if you choose to do two operations, so that would have a different value if you choose to do one. So accordingly, you will have it.
Okay, ma'am.
We will go on to the next question then. So in the sixth, sorry. So this is the sixth question. So here you have to please read the problem and try solving the problem. We'll wait for a few minutes. Okay, let's discuss the problem. So mostly people think it's D. Um, there's some okay, so there is a little bit of confusion in the question. Some people also think it's C or A. Let's see. Okay, so Samyukta, you said the answer would be D, right? So why do you think that's the case?
Yeah, if we take the case of A, there's the flush. So there's a substitution operations. The cost will be 2. In B, we have, you can take the example of stash or flush. We have substitutions there. So it will be 2. And in C, we have bash. So there we are substituting L with B. So we that in all three cases there are substitution operations. So the distance in either of the cases is not found. So it will be none of them.
Okay, okay. Um, um, how about Saurav Kumar? You also think it's okay? Let's see someone who has chosen some different option. Okay, just Ritu has said that it's Ritu Agnihotri. You think you've said the answer would be C. Uh,
Yeah, initially I thought it too, but yeah, when I checked it, like there's a substitution, right, in batch. So the value goes to 2, and every remaining all A and B as said by the previous speaker, they also have substitutions. So yes, D is correct in my opinion.
okay, okay. So I think now we have got a unanimous answer. We'll go over to the solution. So yes, so yeah, so as so the answer is D. So none of the above. So as discussed by like all of you. So in the first few options, there are cases which would give a higher cost, because of which those are getting eliminated. So we can take up such cases. So like it was already discussed though, maybe. So all there in the first two option, there are cases, or first three options, there are cases which has a higher Lewis-time distance. So none of the options are satisfying. So we have the last option, none of these to be the correct answer. Does anybody have any doubt?
Ma'am, I am
Hmm.
confused because I'm not able to understand this question because question says that assume that we will modify the cost include for operations in calculating direction distance. Such that both the insertion and deletion operations include a cost of 1 minute.
Yes.
Means if you do any deletions or insertion, the cost will be 1. While substitution includes, means if you do any substitution, then the cost is 2.
Yes.
Now for the last, which of the following sets of things will have an edit distance of 1 point and control?
Are you confused in like what edit distance would be? So like in the term edit distance, so like so if lash is the source word, so edit distance would mean the number of operations, including insertion, deletion, substitution, all of which must be performed to go from the source word lash to the target word, which may be any of these: ash, slash, clash, flush, like that. So if we have lash to be the starting word that we have, if you want to go to ash, so we are deleting L. So, and here in the problem, it's given that the cost of deletion is 1. So that would mean the edit distance of lash and ash is 1, because one deletion operation was performed to go from lash to ash. Similarly, let's take stash. Okay, I'm looking for something. Uh, let's take this blush. So here what we are doing is, here we are first inserting B, first inserting B at the beginning. So that would mean we have one insertion. So that gives us a cost of 1. Additionally, we're also substituting A with U. So that gives us a Lowest time distance of 2. So the total edit distance for lash and blush would be 1 plus 2, which is 3.
Mm. Yeah,
Yes. Did you get it now?
sorry, I know. But
Yeah,
how
sure.
do
I'll
we
like, yeah. Tell me what the doubt is.
no, because it is mentioned as like we'll have an edit system which shows that we should have a distance of one or we should have a distance of two. How do we find this answer? I am not able to understand this.
Okay, so the so what the question is asking is, so in each of the options there are a few sets of words, right? So it is
Yes,
asking that you have to compute the edit distance of lash with each of the words in the option, and for each of the words the answer should be, for each of the words the edit distance should be 1. For example, if you take C, just let's go over the option C. I think then it would be clear. Okay. So in this case, so I'm starting with lash, right? So if I have to go from
yes.
lash to slash, what do I have to do?
We have substituted yes here.
I have to
Sorry for
insert,
inserted.
right? So
Inserted. So cost is one.
so edit distance would be 1.
Yeah.
Edit distance means the number of, edit distance means the number of operations that I'm doing. So if there's one insertion operation, that means plus one. One deletion plus one. One substitution means plus two. Like that. So for the overall word, you have to calculate. Now let's see the word last. Here, what would be? What is happening?
We have substituted H with P. So the cost is 2.
An edit distance is 2.
Yeah.
So we wanted edit distance to be 1. So this is one violation that we see. What about for bash?
Okay.
Are you understanding? So I'm just going over the
Yes,
exam.
ma'am. Yes.
So what about for
So
bash?
each word we should have a edit distance of only one. We should not cross more than one.
Yeah,
What you mean to say?
yeah. So in this
So
question,
back we have
hmm,
substituted L with P. So the cost is 2.
right,
So for yeah, as we have deleted one, so the cost means deleted L. So the cost is 1.
right. So edit distance
So
would be
we have
1 in which cases? Only in the cases where in the words I've either performed one insertion or one deletion, either one of them. Only if I have all the words in the option satisfy this criteria, only then the edit distance would be 1 as per this problem.
so all the 4 words, whatever is there, it should have only a distance of 1. Means only one operation should have been taken. Means between deletion or insertion.
Correct,
Since
correct.
the cost is only 1.
Yes.
Okay, so got it, ma'am. Thank you, ma'am.
Okay. Um, anybody else has any other doubt? No, right? Okay. Let's see the next problem. So, please try solving this problem and please post your answers. We'll take it up in a few minutes. We'll take it up in a few minutes. One of the students has answered. I'm requesting others to also solve the problem. And like, if you have any doubt, you can ask me now, so we can discuss the doubt also. And let's see a few more minutes, and like, please try the question and post your answers. We'll wait for 2 more minutes, and then we'll go ahead with the solution. I think Pinky Das is saying regarding the recording of previous session. I think it's available in the portal only, in PTL portal. If you log in, you'll be able to access the previous day sessions. Okay. Are everybody stuck with the problem? People are not posting their answers. So, is there any point that is any point of difficulty in this question? Okay, I think we'll go on to the solution. I think maybe okay. So Samyukta had answered. Let's hear her once. Then okay, Samyukta, I think the answer is B. So could you? Yeah.
Add one smoothie. So let's read out the formulas. We have add berries slash dried is equal to, let's see, count of dried berries plus 1 divided by count of dried plus v. So in this formula, we have the p of add 1, that's 0.04, and the count of dried berries we don't know, and count of dried is already given as 580. So we can derive the count of dried berries by using the formula P of berry slash dried into C of dried. So that's point 0.3 into 580. And we get the value of 174. We substitute the value in that we add one matrix. Yeah, add one stable formula. The only thing that is unknown is B. And to solve it, we arrive at B7.
Okay. Okay. Um. So I think yeah, Samyukta covered all the important points. We'll just go with the solution once more. Um, so yeah. So here, as we can see, so here we are using two main formulas. One is the Emily formula, So according to the Emily formula, the probability of berries given dried would be the count of dried comma berries, number of times dried berries occurred divided by the number of times dried occurred. So here the given quantities that are there in the question is the Emily probability is given, the C dried is given, we plug in the values and we get the probability, we get the count of dried and berries, that would be 174. And now we use the formula of add-one smoothing where we again, so here what we do is here the advanced sorting is computed for the berries given dried. So again, as per formula, you just put the values in the formula. So the formula would be C of dried comma berries plus 1 by C of dried plus B. And now we already got the count. So C of dried is given, C of dried comma berries were computed as above. So from that you get the value, a value of the unknown over here, which is the vocabulary, and that gives you 3795. So this was exactly as Samyukta explained. Um, so, so very few people solve the problem. Does anybody have any doubt in this problem?
Ma'am, will that C of dried comma berries, if we interchange them, then it will change or remain same?
This one. So this just means the number of times berries and count occurred together.
No, no, in the formula, we have C of dried comma berries divided by C of dried comma.
Yes, yes.
And the C of dried comma berries, if we interchange them like berries comma dried, then will it remain same or will it change?
It would change. It means number of times dried berries as a whole it appeared in the corpus. So the bigram dried berries occurred.
Okay.
Yes. Any other doubts? You can post in the chat as well, or you can ask if there are any doubts.
Can you show the question answer?
Yes, sure.
Thank you.
Okay. Um,
One question.
yes.
So total vocabulary size, if you say 3795, is it the 5 grams size is 3795 or each words, the total count of words?
Total count of the words.
Count.
I hope everybody understood the solution. If you have any doubt, you can ask later as well. I think we'll go over to the next question. Okay, I'll go over to the next question. So, so here the sentence is so when a corpus is given, you have to calculate the following things. So please try solving the problem. We'll again take a couple of minutes and then we'll discuss. So there are 36 people in the live session currently. I would request all of you to try solving this problem. So try solving the problem and post the answer. We'll surely discuss it. Let's just give it a try once. That it doesn't matter whether like whether it's correct or incorrect. Just try solving the problem, and we'll discuss it soon. Okay. Well, two people have answered till now. Just others also please join in. Please try solving this. Is there any terminologies or any confusion in the problem statement that people want me to explain that would help them solve the problem? You can ask that as well. Like if you're stuck anywhere and figuring out some point, that also you can ask. Because I'm seeing very few people are answering. So only three till now. Okay, we'll discuss the solution. So, among the people who have answered, think B and D, people think would be one of the possible solutions. So let's see, Mukkakamala Rambabu, he has said, I'm getting 1 by 128. So could you please explain the steps that you followed in solving this problem? Okay. Okay, let's take Ashwini then. Ash, yes, somebody has unmuted.
Yeah, that I think I'm getting 1 by 6 into 1 by 6 into 1 by 6. So I was trying like that, man. So there I got stuck.
Oh.
It's not.
So, like, how did you start the problem? So, you first computed the diagrams. That also, if you could just explain the process. It's not the final calculation, just the process I wanted to understand. What did you have a corpus from there? What you do?
There is a big garden, right? So there is again is a big like the diagrams of the this.
Hmm.
Then the probability I'm just trying to find out. So there is a big garden. Then with that I'm just trying to get the probability as 1/6. Again they play inside the beautiful garden. That I'm getting it as again 1/6. So
Okay, 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 okay. Okay. Uh, let's see. Ashwini. Ashwini, you think the answer is D?
Ma'am, yes, ma'am, because I started using this formula that is count by total by grant. So, like giving the percentage. Okay, so here what actually we can put the sentences in the formula, but since we don't have the exact number to calculate the specific count, so we might not get the answer of A, B, C. So I feel D is the correct answer.
Okay, okay, okay,
We can put the formula and we can put these sentences there, but we will not get the exact count. As
okay,
per the sir, how he explained in the
okay. Okay. Um, okay, I'll ask somebody else as well. Let's see. Ashish Sharma has raised his hand. Yes, Ashish?
Ma'am, in this question, first we'll calculate all the diagrams by including stop words at the beginning and end. And for calculating the total probability of the given sentence, we'll calculate the diagram probability of each word which is there in the they play in a big garden, and we'll put their product. So as per that, the answer should come as 1/4. But none of the options had that. So
Okay. Okay. Yeah. The process that you followed was correct. Let's see what the solution is. Okay. We'll just take one more student. Let's see. Mm,
so I'm just getting 1/6 raised to the power 7.
okay. Okay. So okay. Fine. Okay. We'll see the solution. Okay. So let's see. Shiva Kumar thinks it's B. Shiva Kumar, how did you get B? Are you there, Shiva Kumar? Yeah.
Yeah, it's actually the uh, first is the frequency of the bigrams with the given statement with for all the combinations, and then the count of the bigrams again, which will be
I don't need the exact values though. I was just asking like the process. I mean, calculation, we will deal with that later. Just like trying to
okay.
understand whether the process that you all followed is correct. So as you said, you started with the corpus, then you counted the frequencies of the diagrams. From that, you obtained the
Yeah,
probabilities, and you plugged in the final the sentence that is given to get the answer, right? That is, am I
yes,
correct?
that's
Okay.
right. Yeah,
Okay. Okay. We'll now discuss the solution. Let's see. The answer is actually B. So let's see how is that happening. So here when we see that probability of, so this is the sentence that is given to us, right? That they play in a big garden. Since it is given that we are following bigram model, so each word would be dependent on the previous word. So as we stated earlier, so before they we have to add a start of sentence token. After garden we have to add an end of sentence token. So what would, so then if we break down this probability, what would we get? We will get probability of all these things. So we have to multiply all these things. So I'm not stating all of these things. You can of course like, so probability of they given the start of sentence token, play given the previous day, in given play, like that we have to keep on. So those would be the diagram probabilities that we need to compute. Now how do we compute the diagram probabilities? We have to use the corpus over here. So we are given three sentences, that is our corpus in this case, and from there we have to find what is the bigram probability. So let's take, uh, let's take probability of big given A, and let's see how is half coming over here. How is half the bigram probability? So when we write probability of big given A, it would be equal to probability of a big given, a big divided by probability of A, right? So let's see how many times a big appears. A big appears here, and so that gives us a count of 1 in the numerator divided by probability of A. So A occurs twice in the corpus. So by 2, so that gives a count of half. So like that, you have to calculate all the probabilities, and you just simply have to multiply at the end to give us 1 by 12. So is this clear? I think many people would have doubt in this. You can ask, many people had a confusion in this. So is there any point that I need to elaborate, any doubt?
There is a big garden we are not considering. So, and there is a big garden. Three sentences we have given.
These
So there
three.
is a big garden. Children play in a garden. They play
Hmm.
inside a big garden.
Yeah.
Now calculate P of they play in a big garden. Suppose we have to compare now. They play in a big garden. There is a big garden. So how do we take this? Like this, we don't consider at all. Then why the
Sorry, I did not understand your question. Could you please repeat
the
once more?
question is we are calculating P of they play in a big garden.
Yes.
Assuming a bigram language model.
Yes.
Now, what is the purpose of these three sentences that do we not compare with this?
So these sentences are there. So these are the corpus. These will be used to calculate the bigram probability. You cannot take direct evidence from the sentences. Use it as a statistical metric. So use it to count the word occurrences of each of the bigrams and unigrams that we need in the final computation. So that is where you're using a corpus. This is like a corpus. Here just three sentences are given, so you understand. Oh, there's a big garden that is given. So usually the corpuses will be huge, and corpuses are just there to get like to understand which words are occurring most frequently, which occurrence are occurring together most frequently, like that. So those are just for numerical, to calculate the counts and the numerical probabilities. Is that all right?
Ma'am, can I explain once again, ma'am?
Yes, yes, sure.
Let's start from that solution first, and that 1/3, how we got from there only you place that.
Okay, okay, okay. So I'll just explain. So the question is, we have to calculate probability of this sentence. So the sentence is given, they play in a big garden. This is the sentence that is given. I have to calculate the probability of the sentence assuming it's a bigram language model. So in the initial few questions that we had covered, we understood what is a bigram language model. It means a word would be dependent only on the previous word. Okay. Till here I hope it's all right. So how, if a word is dependent only on the previous word, how would this probability be decomposed? So this is a probability of an entire sentence. When I decompose it in terms of the probabilities of a word given the previous word, what would I get? I would get probability of they given the start of sentence token, probability of play given they, probability of in given play, probability of a given in, probability of big given a, probability of garden given big, probability of probability of end of sentence token given garden. Okay. So those are all the probabilities that need to be multiplied. Now I need to calculate each of the individual probabilities. Okay. So this is the first thing, probability of the given the start of sentence token. It means, so how, what would this probability be equal to? It would be equal to probability of start of sentence token day by probability of the start of sentence token. So here the numerator is how many times start of sentence token and they occur together. Like how many times in how many sentences they is in the beginning of the sentence. That is what it means. Given by number how many start of sentence tokens are there in the corpus. So here we see, so they occurs only here. So this would be the only case where start of sentence token and the occurs in the corpus. So that gives a count of 1 for probability of start of sentence token comma they. So in the third sentence, are you able to see the cursor? Um,
Yes,
oh,
ma'am.
okay, okay. So here, so only in this case you get, so this gives us a count of 1 for the numerator, whereas now the denominator is the count of the start of sentence token. So that would be there in each of the sentences. So that is 3. So that gives us 1 by 3. Any doubt in this? Any doubt in the
No,
first?
ma'am.
Okay.
No, ma'am.
Okay, so now let's take the next one also. We'll maybe do the first three, then I'll leave the rest for you all to calculate. So probability of play given day. So what would be? It would be probability of day, comma play divided by probability of day. So how many times they play occurs? They play again occurs in the third sentence only once. They play one, that gives us a count of 1 in the numerator divided by play. Play occurs twice, second and third sentence. So that gives us 2. Just a second. So am I saying something wrong? This is 1 into 1 given. They play. This should be 1 by 2, right? So I think here again, yes.
And I think day is also occurring once. Day.
Oh,
PHA.
sorry. Probability of day would be in the denominator. Right. I was thinking play. Sorry. Yeah, correct. Yeah. So probability of day is in the denominator. So that gives us 1 by 1. Okay, yeah. So again, let's take in probability of in given play. So here in the numerator would be play in divided by probability of play. Play in is here once and play is there twice. So 1 by 2. Yeah. And then finally you just multiply all these things and you get 1 by 12.
We take third also. Sorry, the last
This one. So here what you have to do is, so what would this be? This would be in the numerator we would have probability of garden and then the start of sentence, end of sentence token divided by probability of garden. So the numerator is number of times garden is there in the end of the end of the sentence. So 1, 2, 3 in all the three sentences there is garden end of sentence token, garden end of sentence token, garden end of sentence token, and divided by number of times garden has occurred. So that is also 3. So 3 by 3. Is it okay? Is this clear now?
Yes, ma'am.
Okay. Okay. So still people can ask, I mean, I think this problem had a lot of calculations. I think I'll proceed. Let's come back. In case anybody has any doubt, we'll come back. So this is the ninth question. So considering the same model, now you have to calculate the perplexity. Um, okay, I think we'll directly jump onto the solution. So here the answer is option B. So here, so we calculated the probability to be in the previous question to be 1 by 12. So we take inverse of that and we just take square root to the power 7. So that gives us 1.4.26. Um, maybe we can come, we are just, maybe we have one more question left. I will discuss that one as well. And then we'll directly come up if we have any doubts. We're running out of time.
How you took 7, ma'am?
So, okay, I thought that is to the power of the number of words, but here there are 6 words, so I think it would be 6 only. The 6 words in. Yeah, yeah, 6. So there are 6 words in the sentence, it would be 6 only. Okay. Um, let's go on to the last question. We'll discuss the solution of this problem as well. Um, I was waiting for some people to answer, but nobody has answered yet. So I'll just go on to the solution. Directly jump onto the solution. So here the question is again, we have to again we have a bigram model, but here we are taking add once model. So given that we have to calculate the probability. So here the vocabulary is 11. So vocabulary would be the number of unique words that are there in the corpus. Now simply what we do is in the numerator, for all the terms in the numerator we are adding 1, whereas for all the terms in the denominator we are incrementing that by the count of the vocabulary. Okay, and just we are again recomputing all the values. Very similar to the question 8, we are just adding like 1 and 11 respectively in the numerator and denominator. And finally, again, we are just multiplying both all the values and that would give us the answer. That is option B. So, so any doubt in this
Can
one?
you explain again, ma'am?
Yeah, sure. So in advanced smoothing, what we do is, so we've seen the formula a while back, like, so this is the formula of advanced smoothing. Okay. So here what we do is when we are asked to calculate the bigram probability, in the numerator we have the count of the words plus one, whereas in the denominator we add v, where v is the vocabulary. So in this question that we have, the vocabulary is 11. So you have to simply count the number of unique words that are there in these sentences, and that would give you a count of 11. And once you have that, you simply put in the values. So in the numerator, initially we had done this problem in question 8, right? See these. So it was 1 by 3, 1 by 1 previously. We would be simply adding 1. So 1 plus 1 in the numerator, and the denominator it would be 3 plus 11. So we're incrementing the denominator by the vocabulary, by the number of words in the vocabulary, and the numerator by 1. So that is according to the formulation of advanced smoothing, and we do that for all the probabilities. For all the bigram probabilities that we are calculating, we do the same. Is it okay?
And for this beauty A,
UTA, UTA, where is which one?
Madam, one question. Suppose see this type of
Hmm.
calculations, we are not allowed any calculator or anything there. How can we arrive like this 2.236 into 10 to the power of minus 6 to exam? I
Mm-hmm.
don't think that they won't provide any calculator or anything. So
Okay.
how is it possible to arrive to this solution, this lengthy solution?
That is I'm actually not aware of that whether calculator will be provided or not. You can check that once with the NPTEL team.
Sure, sure.
So
Thank you.
yes.
TCS calculator will be provided, like on a spin calculator.
Okay. Okay.
So it is very tough to calculate, madam, like this. These lengthy questions if we give, then we lose almost 4 marks.
Okay. I think it's fine now. Like just one or two problems would be like that, right? So I think it's okay. Somebody has a doubt. Yes.
How for adding and incremented can you explain again because I'm not
Sure. 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 So I think I'll go back here. So here you see this is the formula of advanced smoothing. So probability of add one for berries given dried. If you forget, if this was not add one, it was not it was a normal uh, Emily based bigram probability you would be calculating. You simply would take the count of the word dried berries in the numerator and count of dried in the denominator. This would be the normal probability. But what happens in add one smoothing is that you increment the count of the bigram by one in the numerator, whereas in the denominator you would be incrementing that by v. So this is the formula. So sir has like in the video also sir has explained. So I think there would be sir has also explained the intuition behind why this is required. So uh, that I think we can explain in the next class. So the next live session. But this is the formula. So now you're simply putting the values in the formula. You're seeing number of times diet berries or whichever is the bigram that you're considering. I think somebody has unmuted. Yeah. So whatever is the value that you're getting, and you simply divide it by the. So these values would be known to you. You just simply add one in the numerator and the vocabulary, the count of the vocabulary in the denominator, and you do that for all the values over here. All the values over here. So does that make sense, or I can should I
Ma'am,
explain again? Yes,
can you explain this beauty given A?
this one beautiful given a this one.
Beautiful, yeah.
Okay, so okay, so here where is it? So beautiful given a in the numerator it would be probability of a beautiful plus one. So a count of a beautiful plus one divided by count of a plus 11. Okay. So we have to see number of times a beautiful has happened in the corpus. Let's see
Like why we are accounting this?
why we are counting this.
Yeah, why we are taking beautiful, beautiful given A?
Why? So this is like we are considering the bigram formulation over here because of that. So you have to break down this probability.
Is there diagram for beautiful given A?
The sentence it's given, right? Oh, beautiful.
So we are considering this sentence, right?
Yes,
Madam, a
Yes,
beautiful is not present in our corpus, but it is asked in question.
beautiful is not there in the corpus.
A beautiful.
Our beautiful
In
is
the
oh.
last sen- in the
Hmm.
last sentence, uh, they play inside beautiful garden.
Hmm.
Or is not there.
Okay, so that is why the count is 0 over here, right? You see
Yes,
0
yes,
over
ma'am.
here, so that is why it's 0 plus 1 divided by number of time A occurs. A occurs twice, right, in the corpus?
Yes, ma'am.
See here and here twice. So that is why 2 plus 11.
okay, ma'am. That means as about half sentence, about last sentence, half is missing. So counting is zero, and implementing is added by one.
Hmm.
And divided by one. That means A is present in the sorry, two like first line and second line. A is present, so that will become the two plus 11. Correct,
Yes,
sir?
yes, yes. And here 11 is the number of words in the vocabulary. Okay. Um, okay. Does anybody have any other doubt?
Ma'am, are we done with this session?
Yes, we are done. We are done with the session.
Thanks a lot.
Yeah. Thank you.
So similar type of questions could be expected in the exam, right?
I think so, but I mean, I'm not the. I won't. I don't have much idea about it. Though.
No, like this kind of questions I can get it.
So the things that you're doing, like the practice problems and the assignments, and whatever is taught in the like lecture videos, those only would be taken up.
Okay.
Okay.
Thank you.
Yes. Thank you.
Thank you.
Thank you. Okay. Okay. Thank you everyone for joining. We'll be closing the
Hello, madam.
session. Yes. Yes. Yes.
I have one doubt.
Yes.
That means actually it is different from your session. What is the application of advanced booking in NLP?
Advanced smoothing in NLP. Uh, so many cases, many words, many bigrams or many n-grams, you won't be observing in a corpus and putting the value to 0. For example, you see over here, a beautiful was not there in the corpus, right?
Yes.
So if you had considered the normal probability, the normal Emily based probability, so that would have given you a value of 0 for this thing. Probability of a beautiful would have probability of 0. Am I correct? And in that, if you plug in the value in the final sentence, probability of they in a beautiful garden, the entire sentence would also have a value of 0. Right? So that is where this so because the corpus so a like a certain paragraph may not be present in the corpus, but it could be still a relevant thing. So because of that, we simply add a value of 1 in the numerator to account for such cases, and we are smoothing in the smoothing. So the ones which were less frequent, we are giving them a value of 1, and in this attempt we'll see the probability distribution gets smoothened. So because of that, so that is the reason we do it.
Okay, madam. Thank you.
Thank you. Okay. um
Thank you, ma'am. Good night. Happy weekend.
okay, thank you, same to you. Okay. So thank you everyone. We'll be closing the session now. Thank you for joining.
I have a doubt, ma'am.
Yes, yes.
Ma'am, I'm getting the count of vocabulary as 10.
Okay. Just a second.
Days occurring once, days occurring twice, in occurring once, eight, two, beautiful one, and garden.
think I think it would be 11 only because I checked it earlier. If you just sit down later with this, I think you would get it. I think we have to calculate it otherwise. One, two, three, four, five. And I also have to like, I think it is 11 only. Just check once more. I think we'll get 11. Okay.